Hello everyone. This is topic 7, stable structures for Science 7. And so the first thing is a stable structure. A stable structure is something that is less likely to tip. And so we want to design structures to be stable. Engineers need to know what features of learning to an object to determine whether it will tip over or stay balanced. And so this is what we're looking at today, is making sure we know how structures stay stable. So, which one is more stable, the ballerina or the baseball player? I'll give you a chance to think about it. If you said the baseball player, you would be correct. Why? The reason is because of the large base. The entirety of the ballerina's put over here, where the baseball player has a much wider stance. Which one is more stable? If you said the sumo wrestler, you would be correct. Now, not just the base here, right? The gymnast has all of their weight over this, where the sumo wrestler is like this, but this person has their weight much higher than this person has his weight. The distance from here to the ground as opposed to here to the ground is smaller. Which one is more stable, the football player or the camper? If you said the football player, you would be correct. Again, wide base versus a narrow base, weight close to the ground compared to the camper, right? But there's more area. This person has 1, 2, 3 points of contact, where this person has like 1, 2, and here we got tippy toe, hand, whereas we just got tippy toe, tippy no, no hand. So this is from your notes. You're going to want to make sure that you are putting this in. Methods for making stable structure. The first thing is rest the structure on a large area and make most of the mass close to the ground. Two key components of making sure that we are getting that structure as stable as possible. Another thing that we need to do is locate the center of gravity. Now that's a point where all the gravitational force may be considered to act, and make sure that we have that over the base. All objects do have what we call a center of gravity, and when objects fall, the center of gravity falls in a straight line. Even as the object is moving over and crumbling over, the center of gravity just goes straight down. Right? If it falls beside the structure or beyond the base, it is not a balanced structure. It will fall over. So here we've got a center of gravity. In each of these cases, a center of gravity is over here. It's a little bit further over. It's still under the base, so this person is still balanced, but it's a little more tippy than this person, where it's right in the middle of the base. This person is now just at the beginning of starting to fall over because we're now beyond the base. This person is definitely falling over, definitely going beyond the base. Here's the center of gravity coming down well beyond the base. Now, the center, a point where an object can be balanced, is that center of gravity. The center of mass is not a point in which all the mass on one side of the point is equal to the other side. Okay, that is one thing first of all. Instead, it's a point that acts as if all the mass were actually centered there, because it depends so much upon the geometric shape. And when an object falls, the center of gravity falls in a straight line. So, lots of acrobats balance things very well in order to make sure that their center of gravity is always over the base, and wind up with some pretty complex situations. Requires a lot of skill and strength to pull this off. Center of gravity, again, is not always just the middle, because if it will be as if all the mass were actually here, where the center from right to left here would be over here, but this key has a center of mass over here. So, little experiment for you guys to try. Try taking a pop can and balancing on its edge. Now, I've seen people even do this on the edge of glasses and whatnot, a little bit more complex, but essentially what you're doing is you're having this. Now, you're going to have just a little bit of liquid in here so that the edge center of gravity winds up being just above this base. Too little liquid or too much liquid, this can will fall over and will not stay balanced, but you get just the right amount of liquid. There is a little bit of give because you got a center of balance anywhere over that edge, but just having just enough liquid in there. So give that one a try. Another thing that you need to do is you need to have a firm foundation, right? You need to make sure you're finding something solid. A lot of times builders put their foundation on a solid material, maybe even digging down to bedrock, or maybe sinking pilings down to the bedrock level. So if you've got, let's say, a house, bedrock is all the way down here, a piling is concrete that goes all the way down, and so it's almost as if you've got your house on stilts. Okay, but those stilts are just totally covered by the ground, but what's it actually staying on is that firm foundation, staying down to a proper level. Now, a firm layer of soil, making sure it's just proper soil density, and in and around Edmonton we've got a lot of clay in our soil, and so they will dig down just until they reach down to a level of clay that is firm enough. Sometimes, though, just due to where it is, we're going to make the solid layer. We're not going to dig down to it. We're going to actually make it. And that can include using things such as a packed gravel and spreading the load around in order to make sure that we're doing it. Right? Road crush, common in retaining walls, sometimes patio sets, smaller rooms, you'll make the solid foundation. Spreading the load out, sometimes many pilings are better than just a few, as the weight will be evenly distributed. And when you're building, a lot of times as you dig things out, there will be a concrete footing, and the footings are laid out in concrete, and the foundation is actually built on the footings, and those footings are completely buried. We use them a little bit wider so that the center is always going to be over the footing, and reduces a lot of the stress of the soil underneath as you're putting it over a larger area, which is actually going to reduce the amount of pressure on each area. Sometimes the foundations are not so firm. Here we see the house where it's sunk. The road crush underneath here was not firm enough. Here we see a whole bunch of just sinking. And here, this total avalanche here. Right? Talked about those pilings. Pilings, again, those cylindrical things right down to the bedrock. Here we see this in terms of construction for some sort of a bridge type project. Always making sure that we're getting down to that something solid. So making sure that we've got a solid compact layer, you're going to compact the layer. Make sure you compact that earth. You put down a road crush. Again, you're going to make sure that it's nice and compact. Lots of heavy machines. Lay the asphalt and then make sure that you make it nice and smooth at the end. Making sure you spread the load. Here we see the footing. And this is the foundation wall. Notice the footing is bigger, and that's again to release this. And the other thing is that we have a drainage system designed to keep water away from the footing. Here's the footing that has been laid out in concrete, where the foundation is going to then come in. Again, the footing wider than the actual walls of the foundation. Now, rapid rotation is another method that we can use for spinning. It's known as a spin stabilization. It's a tendency of an object to spin and move in a predictable manner. The idea here is that if you've got an object that is spinning, okay, if this is spinning, if the mass here is a little bit heavier than here, it's going to fall a little bit, but it's going to keep turning up as it keeps falling with a little bit more, and that weight of gravity is constantly being distributed in a different spot. And because it's constantly being distributed in a different spot, what you're going to find is that the center of mass winds up staying over, whereas if you just try to have it sit there, it would not be there because it's always staying in one place. But as it's rotating, it evens out and centers, shall we say, that center of mass around that point of rotation. Okay, bike, gyroscope, football, satellite, all examples of this. Now, just to show you what this kind of looks like, got a quick little video on spinning a basketball.
Hello everyone, I'm Scooter Christensen. Now when I was a kid, had a free ball on your fingers. Now when I was a kid, this is what I did. Come down here with me. I used to spin the ball just like this. See that circle right there on top of the ball? Same thing. Now what you try to do is spin the ball straight and find the middle of the ball. Just like so. See that? Middle of the ball right there.
So what he's doing is making sure that he's keeping his finger over the center of gravity, which is easily identifiable when you've got the rapid rotation. You saw it's actually a little bit of a larger area.
On top, just like that, as you saw before. Try to balance, just like that.
Okay, so you've got some Topic 7 review questions on lane stable structures and firm foundations. If you got any questions, let me know. Have a great day.